This video will help you understand what motion maps are and how to draw and interpret them. Motion maps are a qualitative way to represent the motion of an object. Other ways to represent motion of an object would be quantitative, and those would include graphical and mathematical models. Motion maps are a visual way to represent an object's motion at various times. Think of an object that is moving by while a photographer is taking a series of pictures, say one picture every second or one picture every tenth of a second. If you could overlay these pictures, you can get a good idea of the motion of an object over time. Essentially, what we will do is shrink down an object down to the size of a dot or a particle and represent its motion over time. So how would we describe the position of a car moving with a constant positive velocity over time? To make a motion map of the car's motion, you first need to draw an arrow representing the positive direction. Most of the time, we assume that the positive direction is to the right. The beginning of the arrow is the reference point. You can see the different distances or positions represented by the hash marks along the arrow. If the object is moving, its position will change over time. This is represented by the dot or particle being at a different location every time interval. Usually the time intervals are 1 second. You place a dot representing the position of the object at time 0, and then a dot for each successive time interval. Let's say the object moved 1 meter per second for 4 seconds. So we drag the initial dot to the origin, that's where the car began or the object began. And then if we assume that the hash marks are 1 meters, then at the first second it would have reached 1 meter. The second would have reached 2 meters. The third second, and then the fourth second. So this shows the particle at each of those successive time intervals. After we draw the dots, we go back and draw in arrows that represent the direction of the motion. The length of the arrow should be about half the distance between the dots. As you can see in this example, we can tell that the object is traveling at a constant velocity because the distance between the dots is the same. Or, in other words, you can tell by the fact that the arrows are the same length. What about if an object is stationary? Well, if an object is stationary, its position will remain the same as time increases. To show that it is remaining stationary, we stack the dots so we can see how long the object remained motionless. For example, let's say the object started at 1 meter and it remained motionless for 4 seconds. 1 second, 2 seconds, 3 seconds, 4 seconds. So this would be the motion map representing an object remaining motionless for 4 seconds. Notice we don't draw any arrows because there is no motion of the object. If the object begins at some positive position in front of the reference point and moves toward the reference point, we say that the velocity is negative. And so the velocity arrows will be pointing in the opposite direction. They will be pointing to the left instead of the right. So in this example, if an object starts at 5 meters, 1, 2, 3, 4, 5, here's its starting point in front of the reference, 5 meters in front of the reference, and it moves at negative 1 meter per second for 3 seconds. So at time 1, it would be at 4 meters, time 2, and time 3. Again, we would need to go back and draw arrows to show the direction of the motion, because without the arrows, it's impossible to tell if it's a positive or a negative velocity. Motion maps can even be used to represent when an object changes directions, as you can see in this example. In your notes, why don't you try to draw this motion map and write down what the motion of the object is doing, and we will check this in class next time I see you.